Hi there, welcome to this lecture. Right before this lecture, there was a file containing some documents that you should have indexed into Elasticsearch. And when you do that, you'll get a mapping for the courses index, okay? And it should look like this. Okay, we have the classroom type in the courses index containing properties such as course description, course publish date, the name of the course, and then the professor that teaches that course. And this is actually an object field. So inside of professor, we have further properties such as the department the professor works for, the email of the professor, the faculty type, whether he's part-time or full-time, and then the name, of course, the name of that professor. And then there's also a field called room. This actually belongs to the courses type. It's not within professors. And then there's also the amount of students that are enrolled into the particular course, right? So when you double click on this professor field, you'll notice that these are the different fields that are within the professor object. And then outside of here, we got the room and the students enrolled. That's part of the larger document, okay? So hopefully you went through the process of indexing all of those documents. If you have not done this, please go back one step, okay, right before this lecture and index those documents into the courses index as I've described in the instructions. Now we'll be learning how to query Elasticsearch. I went ahead and indexed all of those documents so we can begin talking about how to query Elasticsearch. So Elasticsearch is HTTP and JSON, right? That's what it is. Everything in Elasticsearch is JSON over HTTP, okay? We provide the HTTP URL endpoint, right? Whether, for indexing or for querying. And the body of the HTTP request contains the JSON to send as part of the request. Now, the JSON structure that I've been showing you so far in the courses has mostly been related to indexing. You saw how you can define an index with mappings and settings, and the JSON we used for creating the mapping and creating the settings, that's a specific structure, and this is known as the DSL for Elasticsearch. DSL stands for domain specific language. It's a specific structure of the language that Elasticsearch can understand. If you get the structure wrong, for example, here we have the properties field in the classroom type inside of this thing called mappings. If you mix this structure up, Elasticsearch is not going to understand. This DSL is in the form of JSON, and we use it to interact with Elasticsearch, whether for querying or for indexing. And if you get the syntax for this language incorrect, Elasticsearch will show the error and ask you to modify the JSON structure you sent as part of the request body. So like I said, you've been using the indexing aspect of this DSL. Now we'll get into the heart of the language, which is for querying, for search. That's the true power of Elasticsearch, and the remainder of this course will be mostly on querying Elasticsearch using the language that Elasticsearch understands. Now, querying has one objective, right? And that is to match your search criteria and provide some kind of relevancy score, right? So for example, if you search for the word technology in your cluster, right, in the documents that contain that word will be returned by Elasticsearch. Now, some documents may contain many occurrences of this word, whereas other documents may only, have this word being shown just once somewhere in the document. So the documents that contain more occurrences of this particular search term, right, the word technology, the documents that contain more occurrences of this word are going to be considered more relevant. Okay, this is very important for you to understand. So Elasticsearch provides something called a relevancy score so that more relevant documents appear towards the top of the search results. That's the basic idea behind searching anything Elasticsearch. You've got the results and a score to represent how relevant the results are to your search criteria. Now, that's really the only purpose of Elasticsearch, but it, of course, provides many more features related to queries, as you'll see. So let's talk about the syntax for the search DSL. There are two major kinds of search syntax components you can use in Elastic. One of them is called the query context, which is used for full text searches. And that's supposed to match documents that contain the search criteria, as well as specify how well the document matched that particular search criteria by providing that relevancy score that I was talking about. And this is all provided as part of the response. The other kind of search syntax component in Elasticsearch is called the filter context. And we'll talk about filters later, but both the query context and the filter context can be combined together to form one large query. So you got two major components of the search DSL. Write this down. This is an important fundamental structure to the language that you'll be using. You got queries and you got filters. In this lecture, we'll only be talking about the query context, and then in the next lesson, we'll talk about the filter context. And then finally, I'll show you how to combine both of these two DSL components, the query and the filter, to form more complex filtered queries. So let's begin working with the query component of this DSL. The most basic kind of query in Elasticsearch is the match all query. So let me paste that here. So notice there's a GET request for the courses index, and I'm specifying the search endpoint _search. All right, this is the endpoint that you want to be sending all of your search requests to. And the requests body is right here. And we, of course, specify that this is a query, and then inside of this query, we specify what we want to do. So this is just a basic match all query. This is going to return everything in the courses index. So let's hit play and notice that we get a total of 10 hits. Notice this number total, and it says 10 for the hits. And the actual hits, these are the different documents that we get, are right here inside of this array structure. So all of these documents here are inside of this array structure called hits, and you can read through each one of these documents. This is exactly the documents that you should have indexed in the previous, right before this lecture. So since I'm not specifying, to match on a particular criteria, I'm just saying match all, it's giving me everything. And notice that the score field right here exists on every single one of these documents. So right here, it's the score 1. Over here, this also gets the score 1. And down here, this also gets the score 1, and so on. For each and every one of these documents that are returned, the score you'll see is just 1. And this is the relevancy score that I was talking about. All of these documents are equally relevant because they have the same score. The reason is because my search criteria didn't specify anything specific. I'm just saying match all. So it's going to return me all of these documents, and they're all equally relevant according to my match all search criteria. Let's get more specific. Let's say we want to get those documents that have a particular value for a given field. Instead of match all, I could just say match. And inside of this, in these curly braces, inside of the JSON, I can say that the name field should contain the value computer. Okay? And just really quickly, before I run this, let's just take a look at what we expect to see. So this is the name of the course, right? So this course is anthropology, so we certainly don't expect that one to show up in the result. This should show up, right? Because the name computer is the course name. And then going up, accounting is not going to show up. These are accounting courses, they're not going to show up. There's another one, Computer Science 101. This should also show up, okay? And I think those are the only two computer-related courses here in this document, in the documents that we indexed, if I remember correctly. But anyway, let's hit run. And there we go. Notice that the total hits is 2. And notice that these are the two documents that were returned. We got Computer Science 101, and we got Computer Internals 250. Now take a look at the score field. All right, take a look at this field. Notice that it has a particular score. It's no longer 1. This is saying 0.814, and then down here, the second document is 0.556. So which has a larger score? This document has a larger score compared to this one, meaning that this document is slightly more relevant than the one below it, okay? And you might be thinking, well, they both contain the word computer. How is this more relevant? This is a tricky question, but there's a lot that goes on behind the scenes in terms of the engineering. But in simple terms, this computer, the word computer here in this field name, has more significance for this field compared to this field. All right. And there are other pieces to this, but simply put, if you count the number of characters, 1, 2, 3, 4, 5, 6, 7, all the way down to here, and then you count the number of characters here, you'll notice that this right here has more characters, and computer has a slightly less significance here than the name here. All right, this has less characters, so the word computer takes up more significance in this field. And this is not the only aspect. Elasticsearch is very smart, so there's a lot of things going on behind the scenes. But if I was to, for example, reindex this document where it says computer internals, ID 7, right, the document 7, if I was to reindex it with computer, with repeats in the name, this is going to become slightly more relevant than the one you see up here. It's going to have a slightly higher score. So let me show you how that looks. I've already got that document on the side here. I'm going to paste it and change the values for the name of the course. So here, this is that document, ID 7, with the name computer internals. And instead of internals, if I just make this computer, I know it's a silly name, but just for this example, and I index this, let's press play. Now this document has been indexed. Notice the version has been incremented to 2, so this has been updated, right? Now let's run that same query. This is that query, and hit play. And notice now that the computer course has a higher score. All right. Notice this max score field inside of this hits component, right? Inside of this hits object, before we get to the documents, it tells that one of the documents has a max score, and that's what this is. And you'll see that this computer has 0.815. This is the max score, meaning this is the most relevant in our search criteria. If you go down, notice that this course has slightly less significance, or relevance rather. It's 8142, and this is 8154. So it's slightly, this is slightly less relevant than this one, okay? Now there's a lot more going on behind the scenes. It's not important to go over into those details, but this should give you a general idea as to how Elasticsearch figures out relevancy. I encourage you to read the documentation. There are some mathematical formulas that Elasticsearch uses. So if you really want to be a hero in Elasticsearch, you can memorize those formulas, but you don't really need to know those formulas to use Elasticsearch effectively. So let's change this to match all again and get rid of this specific criteria. I just want to see all the documents again. Here are all of the documents. One of the documents here has an email field that is empty. So for example, this professor for the course Theater 410, his name is Sebastian Hearn, this professor, his email field is empty, okay? Whereas all the other emails for the professors have been populated with the email address, all right? So this document here, document with the ID 5, doesn't have an email address. So if we wanted to get only those documents that have this field populated, what would that query look like? Well, we could use this component called exists. And inside of here, we specify the field that we want to make sure exists on the document. And that's going to be professor.email. Okay? Notice I can't use email directly because email is a component within professor. Okay? It's an attribute. It's a field that is within professor. So to access this field specifically, I can't just put email. I need to put professor.email. That's the official field name, okay, for this email field. So now when I hit play, I should only see a total of 9 documents that get returned. And this particular document with Theater 410 should not be in the search result. So let's hit play. And whoops, it looks like it's still there. And the reason is because it's checking for whether this field exists, all right? Not that this field has a value, right? This exists clause checks for whether this document has this given field. And so since this document does have this field, even though it's empty, It doesn't have any value in it, but this field does still exist on the document. So let me just re-index this document, right, and change the, get rid of this particular field completely. So here's that document with the ID 5. This is the same one that you indexed. So just get rid of this email field completely. Okay, just get rid of that just like that. And we only have these 3 fields. And hit play, and that should overwrite the existing document. Notice the version has been updated to 2. The result is updated. Okay, so now going back to our query, just do Control-Z to go back to this query. Let's hit play, and now notice that we only get 9 results, right? Total 9, and you wouldn't see the document for Theater 410, right? That course has been removed from the results, okay? Because that field, professor.email, doesn't even exist on the particular document, okay? So there's another query to keep in mind. So far you've seen the match parameter, the match all parameter, and this is another one, the exists parameter, and these all belong inside of this query parameter, okay? Let's go back to match. If I change this back to match, and then I want to say that the name field should match, the word computer. Okay, let's hit play, and this is going to return those 2 computer courses that we have. One of them we renamed to Computer 250, and the other one is just Computer Science, okay? If I want to get more specific, and instead of just having one match, I want to match it on 2 criteria. So here is the criteria. The name should be containing the word computer. If I wanted to add another match criteria, such as, for example, the classroom should be, for example, C8. All right, this guy right here. This is a different room. This is C12. Computer science is taught in room C12. Computer is taught in C8. So if I wanted to match on not only the course name containing the word computer, but also that it's taught in room C8, how would I do that? Notice that there's an X here saying duplicate key match, right? Syntax error. So this is a syntax error. We have, duplicate key. This match field is being repeated here, and this is just incorrect JSON. So to make this work, it needs to go into something called a must clause, all right? And that goes like this, must must, and the values for this is going to be inside of an array, so we can have multiple fields in there. Let's cut that and paste it here, all right? And not only that, we have to wrap these in a JSON structure, okay? That's just correct JSON syntax. So we put those curly braces around the first match criteria, and then we put the curly braces around the second match criteria. All right, so we're almost done here. This is now it's saying that must, both of these should be true. That's what this must keyword means here. And this is part of the query DSL. You'll have to memorize it. Name must contain the word computer, and room must have the value C8. But this is not going to run just like that. If I hit play, notice it's saying parsing exception, query malformed. There is one other piece to this. We need to wrap this must thing inside of something called a bool. All right, and bool basically is a Boolean, true or false, and those are, you can consider those Boolean expressions. So it goes into something called a bool, and we specify inside of the bool, right, inside of this bool structure, we have to take this must and dump it in there like that. All right, and now this is valid JSON. Not only is it valid JSON, but it's valid Elasticsearch DSL query. Okay, so let's hit play, and there you go. Now it's returning the values. So notice the results, the hits is only one return. This is just one hit. Max score doesn't really matter, just one document. It's giving a high score, whatever. And notice this is that document. The room is C8, and the name of the course is Computer 250. But hey, look, this lesson is about to cross the 20-minute mark, so I'm just going to wrap it up just before that, and we're going to continue on this subject in the next lesson. So stay tuned. I'll see you in the next lecture.